Hi everyone, I'm Nicolai, also known as Nicolai, and today it's going to be you, me and Java generics. The other day I spent an evening on Twitch going through the topic, starting with the very basics and going all the way through more advanced applications. And a couple of people later asked me whether they could rewatch it somehow, and while Twitch keeps the VODs around for a while, I thought I'd publish it here on YouTube. So I went through the material, cleaned it up, cut it into shorter pieces, and so what you're going to see now is the first part. This is going to be the basics and the application to a couple of small demo classes, and more is going to follow if you want me to. If you want to? I guess if you want to, right? So yes, leave a like on the video and subscribe to the channel and go to Twitter and Twitch, and I'm Nicolai everywhere and that part. And I hope to see you around. Have fun, bye! So why even talk about generics? Why do we even need generics for? What do we need them for? And as a motivating example, I want to start with this gift box. The gift box wraps a gift, and it can wrap one, and it can unwrap one. So far, so good. And you can already see, like, you know, a box can wrap everything, so that everything's an object here. Now, while surprises are great when it's about presents, it's not good when we talk about code. It should be ideally, surprise-free. So when I get a present here, and I want to unwrap it, I kind of need to know what's in there. I'm hoping I get a tablet, so I cast to tablet, but you know, this might or might not work, of course. So because this returns object, and I rarely can do anything useful with an object, I basically have to cast to do anything important. And the thing is that while giftbox wraps anything, this anything is fluent. It wraps anything and unwraps anything, and both are the same anythings, right? So when I wrap, I can wrap a 0, which is an integer. I can wrap a tablet, which in this case is a string. I can unwrap it into an object. That always works. But if I want to do anything specific with it, I have to know what's in there, as I mentioned earlier. And what we do with generics is, so first of all, right, this case here, this is the thing that can fail, of course. If I have to know what's in there, and if I don't know what's in there, I get it blows up. So this is an integer, this is a string, neither of those is a tablet instance. So in any case, it explodes here. So what generics means, it means to give that anything a name. Capture this anything in a variable, or in a parameter rather, and then reuse that. Well, actually no, a variable thing is quite fair. Capture it in a variable, and then reuse that in different places. And then the compiler can make sure that you do the correct thing. When you generify a class, meaning when you take a class that has no generics and you start putting a generic type in it, it starts with you have to declare a type variable. And you declare a type variable by attaching this angle brackets with a t in there, or whatever really, oh yeah, let's talk about that quickly at least. Let's talk about type variable naming. So, right, when we can declare a type variable, this declares a type variable, and this makes giftbox t a generic class. That's how I usually put it. And now we can start reusing t wherever we want, really. So here, for example, we use it as the type of a field. And then if it wraps, the gift is a t, then it kind of makes sense that we only want to wrap, or rather, if it's a giftbox of t's, giftbox of whatever, tablets, then it makes sense that we just want to wrap things that are t, and we just want to unwrap things that are t. Now, conceptually, what you could imagine this to be working like is if you create a giftbox of tablet, and yes, if you think you don't have to put this in both places, you are right, we'll come to that. If you say I want to create a giftbox of tablet, then that's basically as if you take the class we had earlier with the object, and wherever you mean tablet, you put tablet in there. So now, or if you take the generic class, it means you put tablet in wherever t appeared, right? So you can put it in front of the field, and then the argument here and the return type here. So you can see it here, here, and here. That's the that's the way that works conceptually. This is not what happens in practice. This is really important to understand. Like if you think about how can I figure out at runtime whether I have a gift box of tablet or a gift box of string, then you're going down the wrong path. That won't work. At runtime, it's just a gift box. In generics are mostly just a compiler fiction where the compiler checks everything, and in the end, it's not entirely true, but mostly true, you end up with a class file that just looks like any other class file without generics, with just object in there. So in this case, you can think of a gift box of tablet like a tablet gift box where just every t is replaced with tablet. I generified gift box and added a t parameter here, and now it's type safe because the type of present is no longer a surprise, right? I know that if I have a gift box of tablet and I call unwrap, I actually get a tablet back. That's good. And the compiler can verify that. The compiler can say, yes, you get a tablet back. That's pretty good. Now, let's assume a more complicated a more complicated gift box, which has a couple of methods on it, but it doesn't really have the simple unwrap. Let's say the gift box API is a bit more complicated, has read card and remove ribbon and remove wrapping paper and then open, and then I only get my present then. Right, so this type is a little bit more complex and it's hidden somewhere and I can't change it. And so I want to write my own method that handles it. And now what I have here is I have a method that takes a gift box and unwraps the present, and it returns something, it returns the present. Now the thing is, what I want to express here is, I want to express that the gift box of t, let's say I would get a gift box of t, I would then give you back a t. Right? But there's no t around here. So, but the thing is, the method wants to be generic too. This is where I'm going with this. The method wants to be generic. The method wants to express, if you give me a big gift box of tablet, I can give you a tablet. If you give me a gift box of string, I give you a string. And we can do that. We can, once again, declare a generic parameter, a generic variable, and once again, a type variable, and we can declare that not only for types, but also for methods. So if we put the angle brackets t here, that goes after the public and, after the visibility modifier, and then maybe there's a static in there too. And that's when the next thing that comes is then optionally, if you want to have one, that's where you can declare a type variable. So you declare a type variable of type t, and then I can keep using it. So after I close this angle bracket, from there on, I can use the t as a type variable. And so once again, I say, okay, if you give me a gift box of t, I can give you back a t. So this is exactly what I said earlier, but instead of saying, if you give me a gift box of anything, I give you back anything, and both anythings are potentially different, now I can promise you, if you give me a gift box of anything, I can give you that specific anything back. So gift box of t, I give you a t. Right. And now technically, if I want to call that, I would have to say, this is apparently the utility class that contained the unwrap method. I would have to say dot and then specify the generic type there to get to specify it on call. Now I come to that. Is it this next slide? No, I come to that later, that we don't actually need to put that here. And that led to the fact that many people, me included, learned about this either not yet or way after they learned about how the entire generic methods work. So I knew you could write the generic methods. At some point I learned that. And then it took me quite a while to realize that I can actually put the type here, because occasionally you have to. I'll talk about that later when I explain why it's not there. So we can have type variables for classes and methods. And if you have one for a class, they can use it in all instance fields and methods, but it cannot be used in static fields and methods. That's another thing that you have to realize. So if you have a whole gift box of t, then this could be a gift box of string or integer or tablet, could be all kinds of gift boxes. But the class itself, right? So if you're not talking about a concrete instance, a concrete instance will always be a gift box of something specific. But the class as a whole is just a gift box, period. The class as a whole is not a gift box of anything specific. And that means that everything that operates just on the level of the entire class, meaning static methods and static fields, they don't have access to the type variable. Which makes sense, because assume I could write Let's just say, jump into some code and write something that doesn't actually work. So of course I can say private final t whatever. Right? Okay, so I can do that. And now this makes sense, this is right, because like if I have a specific instance of giftbox, it will know that it's a giftbox of integer, and then this field will be integer. What I cannot do is private static t whatever is null, because I could have a giftbox of string and a giftbox of tablet and a giftbox of integer, and then what the hell would the static field be of what type? That doesn't even really make sense to consider that. So the generic type variable only exists on the level of concrete instances. It doesn't exist on the level of the class as a whole, and that's why you cannot use it in static fields or static methods. But static methods can still have their own generic, their own type variables, just like instance methods can have as well, as I showed earlier. So let's have a look now, classes versus methods. The giftbox of t here, as I earlier, declares a t field and then uses it here. And then I have these other couple of methods here, right? Read card and remove ribbon or whatever. And now in this case, let's say that unwrap is a static method again that gets the specific giftbox given to it. It's not a good API, doesn't make sense, but let's assume that's the case. Then what is common is to use the same type here, right? So this t looks like this t up here, but it's not. Right? Static methods don't have access to this t. It's just a new type variable with accidentally the same name. And that can sometimes be a bit confusing. You don't have to put the types there all the time yourself. For generic, if you construct a generic class, then you can just use the so-called diamond operator, where you just leave out the entire type here because the compiler can infer it from the left-hand side. And for generic methods, you can just leave it out entirely and just call them like this, and then the compiler will figure it out. Because if you remember unwrap, then yes, it needs a type here technically to define what that t is. That t is a tablet. But it knows that whatever t you give it here, that will also be the type of this box. And this box is a giftbox of tablet. So it knows if you call with the giftbox of tablet, then it looks like you probably want to have a tablet here. And it also checks with the return type and sees, oh, and you want to have a tablet here, so that works. What it would actually do is it will put the requirements for type inference, it will put all the requirements for these types that are not defined explicitly into a set of equations and solve them. Meaning, hey, I don't know the type here, let me infer it. So I know that this is a t, and I know that what you give me here should be a giftbox of t, and I know that what you return here should also be of type t. And now let's see if we can make this work with the concrete variables that I have here. And hey, it works. Apparently t is tablet. So there it goes. Okay, so type inference. Type inference works really well, but sometimes it doesn't. Sometimes it infers the wrong type, and you just get a compile error saying I inferred this type and it doesn't work. And sometimes it's kind of hard to keep the code readable if this information is not there. So in such cases, it helps to put it there explicitly. Hey, it's me again. Sorry to interrupt. Nicolai is now done with the theory and starts to write some actual code based on the class that is already there, but he does a shit job explaining what it does in the first place. So the class is a node, which is part of a larger tree structure, and a node has an object as content and has a list as children. And that's all there is to it. But if you want to take a closer look, pause a few seconds in and you can study the source code. Let's start generifying this. So the thing is, let's have a look at the node. Public class node, okay, that's fine. It has an object as a content, and then you can get the content and set the content because, but yeah, there we go, we can get and set that. And there are no generics around here at all. So if you want to get the children, you just get an iterable. And if you want to iterate over that, you just get objects back and you have to cast them to node. I think I do that somewhere actually, and it's not nice. Here. So I get a node, I get the children, but the children are just objects. I mean, I know they're nodes, but no, without generics, iterable couldn't tell me. So now I want to add generics here. And so what I basically want to do as a first thing, I want to say like this node is of type t. And now we can start to talk about names a bit. It's common to use T for type or E for element, but I actually started to use longer names. They work just as well, they're just uncommon, but I saw it somewhere and it kind of convinced me that it's a good thing. I mean, this is the type variable for the type of content. I think that's a fair name for the type. So I think that's better actually. So now if you do this, then you can often be guided by compile errors, because the compiler will now say, do you say that this is of type content, whatever content is exactly, but it's of that type, or content is an object. Well, this doesn't work, right? You cannot generally assign object to content. So yeah, I have to put object content here, and then here as well. And then, for example, there's a compile error anymore, but if I get children, if I get the content, where is it? There, if I get the content, I don't want to make it more general than it has to be, so I can actually give back content as well. So children, what are these children? Are these a list of contents? Oh no, shit, now we don't get the correct compile error here. No, they're actually not. They're a list of node of content, right? Our kids are nodes. And we have to put this here to basically activate the generics mode for array list. And this is still bugging me. What else do we get here, for example? Add child, we have to say it's child of content. And then the iterable. Our children is an iterable, like getting the children is an iterable of node of content. So the exercise that I didn't show you, the exercise here is that the node has a specific kind of content. And then we want to have a tree of just that kind of content, right? So we want to say a tree has nodes of only strings or only integers or whatever. So now we start adding it here as well. Should be fairly quick. There's that, and then I want to take content here as well. And this is a static method, so content doesn't exist here. So we have to add it here as well. And then we can remove a couple of casts. That's pretty good. So for example, here we know that the children are a node of content. So then we don't have to cast here anymore. And then we get a node of content here. And that fixes this. God, I have to return now here and I feel so dirty. And that also means here, I have to pass on the content. So I have to switch this to content. And that's that up here. Then to get the root, also node of content. And this is an interesting one. Yeah, that's a very interesting one because it requires recursive generics. But that has to wait until the next video. Until then, you can catch me on Twitch, where I usually stream on Tuesdays and Thursdays, or on Twitter, as I mentioned, NipaFX. I'll see you around. Have a good time. So long! I'm trying a new thing, and the new thing is I'm trying not to scream as much, because my family is sleeping there, and that has been kind of a limiting factor on how much I can stream, or how my family and I start to call it how much I can scream during the evenings.